Hi, my name is Jesse Wells, and today I'm going to be doing a sample problem similar to your question 38 of your chapter 4 homework. So for your question, right, I'm going to have a lot more scores and then I guess like a more reliable variance, but I hope in the example solutions I'm going to give you, you kind of get a basic framework of what you're supposed to do, and then kind of understand how you could apply that larger idea to the study that was listed in your work. So what the question first asks you to do, and it's part A, is to find the standard deviation within each pre-test, post-test in group 1, and then pre-test and post-test in group 2. All four of these things individually, as well as the mean of each scoring. And so it is quite a little bit, but it will very much help you in part B to kind of understand how we can apply this to a real world sample. So first, to start with anything, let's start with our mean. I'm going to start with group 1, our pre-test, then go post-test, then go to group 2 pre-test, and then our group 2 post-test. So let's start with group 1 pre-test. Their scores are 2 plus 8 plus 7. 2 plus 8 being 10 plus 7 being 17. We have 3 scores in each of our groups, but for a pretest, our number of scores is 3, so 17 divided by 3 will be 5.67. This is our mean. I'm just going to put group 1 pretest right here next to it so we can put it all together at the end. Now we're going to go from that mean to find our sum of squared deviations, and then from there find our variance, and then finally find our population standard deviation. So yeah, we're going to take each of our scores, 2, 8, 7, and then minus 5.67 from each of them. So 2 minus 5.67 is negative 3.67. 8 minus 5.67 is 2.33. And then lastly, 7 minus 5.67 is equal to 1.33. And so adding these all together, oh sorry, not adding them all together, squaring each of them individually, we'll do 3.67 squared, which is 13.47. It's positive because of that negative right there. 2.33 squared will be 5.43. And then lastly, 1.33 squared will be 1.77. Adding these all up together, we get 5.43 plus 13.47. We should get 20.67 being our variance. Now that we have our variance, we just square that, and we will get what we're actually looking for, being our standard deviation, which our standard deviation will be 4.55 5. So these are the two things we're looking for. And then we do that 3 more times. So we're going to go to the next portion. Now we're doing post-test. So we have, for a post-test, we have 20 plus 22 plus 26. We're finding our mean now. Let me put a little marker down there. So 20 plus 22 plus 26 will equal 68. Divide that by 3 will be 2.67. We're now going to minus that from each of our scores. 22. We're just doing exactly what we did earlier, but just 3 more times, essentially. 2.67. This will be 20 minus 22.6. Oops. 20 minus 22.67. My goodness. 20 minus 22.67 is negative 2.67. This should be 0.67, and then 26 minus 22.67 will be minus 22.67. 3.33. Square each of them. Just gonna work upwards. 11.09. 0.67 squared will be 0.45, and then negative 2.67 squared will be 7.13. And now we add them up. 7.13 plus 0.45 plus 11.09 will be our summation is equal to 18.67. So let's first, before going any further, make sure that we note that our mean is 22.67. Now let's continue on, so we can find our actual standard deviation. So we're going to take this, our sum of summations, we're going to divide that by our amount of scores, being 3. Divide this by 3 is equal to 6.22. And then square that. Square it. So our standard deviation will be equal to 2.49. Okay. I might grab another page, but we're going to be using the same scores as before. We're going to do group 2 pre-test. We have 2, 7, 3. Post-test 10, 7, 22. Our pre-test, we're going to find the mean of our pre-test for group 2. 7 plus 2 is 9, plus 3 is 12. Divided by 3 is equal to 4 is our mean. We're going to then do what we did before and minus our mean from each of our scores. So minus 4, minus 4, minus 4. 2 minus 4 is equal to negative 2. 7 minus 4 is equal to 3. 3 minus 4 is equal to negative 1. We're going to square each of these. So this will be 4, 9, 1. Add them up together. 14 will equal our sum of summations. We're then going to divide 14 by our number of scores, being 3, which will equal, divided by 3 will equal 4.67. And then we'll just square that to get our standard deviation, which that will be equal to 2.16. One last time, we got one more time through it. Thank you for sticking with me. So let's do it. So 10 plus 7 to find our mean. 10 plus 7, 17 plus 22 is 39. 39 divided by 3 is equal to 13. We're going to list out all our scores again. Minus 13 from each is equal to -3 is equal to, oh my goodness, if I can do math in my head, -6. I can't do math in my head, that's why I had to use my calculator. 22 minus 13 equal 9. We're going to square each of these scores. 3 times 3 is 9. No negative because it's squaring it by itself. This will be 36. And then 9 times 9 is 81. And then we add all these scores up together to get our sum of summations. Plus 36 plus 9. This will be our SS is equal to 126. Then we do what we did before, and we divide our sum of summations by our number of scores. Equal 42 will be our variance. And then we square that to get our standard deviation. So square root of 42 is 6.48. Okay. So now we should have all of our available data that we need. And so I'm just going to take all that we had from our first couple of portions of the problem, and then what we have for our second group, and we'll compare it. So group 1 had a mean of, group 1 pre-test had a mean of 5.67 and a variance of 4.55. Post-test had a mean of 22.67 and a variance of 2.49. This is also not a negative, that's just a regular 4. Group 2 had a mean of 4, a variance of 2.16, and then a post-test of, our post-test had mean of 13 and a variance of 6.48. And so when we compare all our data together, right, we can kind of see a trend for our first group to have very differing means. So on your example, right, you should probably see like a higher amount of student success in the first group than in the second group after they've had a bit of a study session. The average should be higher than the one beforehand. But for the second one, I tried to make it so you shouldn't see much difference between the means because the scores are kind of scattered. Or not scattered, but similar in like there's not much improvement. As for variance, you should see in group 1, everyone increased their score, all kind of in the same way. So variance should stay low just because no one got an extremely high score. There wasn't that much of like a scattered amount of scoring like before test and after test versus group 2. There's not much improvement, or there's more like scattered improvement. Some people did very well comparatively and some people did very poorly comparatively. And so you just kind of need to look at what data you have and kind of draw a conclusion from that in like a real world perspective. Did the pre-test change over time once studying was given to the post-test? Did it not have an effect? And that's just kind of how researchers use statistics to validate like what helps a student, like in our textbook example. So yeah, I know that was a lot. Thank you for sticking with me. And if there's any help that you need, feel free to reach out. Thank you very much.